Dear students, today we are going to see how to do the backpropagation in artificial neural network with manual calculations. That's how we are doing the forward pass and backward pass with manual calculations. So before going into actual code, you need some revision on the formulas. Okay, that's why I have opened this slide. Now, as you can see, this is an artificial neural network in which in the input layer we are having 3 neurons. Then in the next layer, we are calling it as a hidden layer, and it is having 2 neurons. And final layer is the output layer, which is containing only 1 neuron. And the weights that are connecting the neuron 1 to neuron 4 are represented with the symbol W14. Okay. In the same way, the weight which is connecting the neuron 2 to 4 is represented by the symbol W24. Means the first suffix should represent the previous layer, while the second suffix should represent the next layer. That you should remember. Okay. So when a neural network is given to you, you will be given the information how many neurons are there in the input layer, how many neurons are there in the output layer, and how many neurons are there in the hidden layer, and how many such hidden layers are there. Okay. And all the weights and bias value will be given to you. Okay. Now, let us see what is the formula. Okay. Now, we know that first we will take what is the value for input. Then that input will be multiplied with the weight. And like this, all the inputs will be multiplied with the corresponding weights. And you have to add them. Then that will become a scalar product. So here is your scalar product. Then to the scalar product, again you have to add the bias. Okay. And then it will be applied to the activation function. Then you will get the output at that particular level. Okay. Now here the neurons are 4 and 5. That's why you should get the output at the neurons 4 and 5 by applying the same formula. Okay. And again, you should get the final output for which these two outputs, means the output of two hidden neurons, will become as an input to your final output. Okay. Now, this is all about your forward pass, means in which you have moved from the input layer to the output layer. Now, at the output layer, I have predicted some output, but I'm not satisfied with that output because my loss is more. But how I'm calculating loss? The difference between your output that is predicted and the difference between your target output is called as a loss. Now, when that loss is more, my aim to get my model trained properly, I should reduce that loss. Then in that case, which algorithm I am going to apply? The backpropagation algorithm. Okay. Now in backpropagation algorithm, why the name backpropagation is there? Because I am moving in backward direction, that is from the output layer to hidden layer to the input layer. And while moving in this backward direction, I should update the weights and corresponding bias. Now for weight updation, first you should calculate the error. Now, there are different formulas to calculate the error at the output layer and to calculate the error at the hidden layer. You can see that to calculate the error at the output layer, I need output multiplied by 1 minus output. That is the derivative of output I need. Along with it, I need the difference between the target output and predicted output. That is the loss. So, this formula will give you the error at the output layer. Now I should know error at the hidden layer also. So for that purpose, the error at the output layer will act as the input and that will be multiplied with the weight. Okay. You have error at this neuron. Now these weights will be multiplied with that error. Then you will get the error at these two hidden neurons. So that error is multiplied with the weight summation and it is multiplied with the derivative of the output. Derivative of output means what? O multiplied by 1 minus O. That is called as a derivative. So using this formula, you will get the error at the hidden layer. Then what I will do? Error at the output layer, when multiplied with the output and the learning rate, then I will get the weight increment. Then that weight increment I should add to the original weight. Then I will get my weight updated. In the same way for bias, you will multiply the learning rate with error. But here, the output will not be multiplied. to get the bias increment. Then this bias will be added to the original bias and you will get to the updated bias. So these are all the formulas you should remember while you are implementing the code for the forward pass and backward pass. Now let us see the code. Okay. Now here I have implemented forward pass and backward pass for which gate? XOR gate. Now you know how your XOR gate is operating. When your both the inputs, that is the X1 and X2 are 0, you will get the output via 0. When both are different, means 0 and 1, or 1 and 0, then only you will get the output as 1, 1. Again, both are same, you will get the output as 0. So like this, you should construct a array and that array will become my dependent and independent variables. Okay. Now, as we have seen, in forward pass, I need an activation function that is a sigmoid. Hence, I'm writing one function by applying the sigmoid formula. That is 1 divided by 1 plus e raised to minus x. Even you have seen that we are multiplying O with 1 minus O. Means we are deriving it. Okay. So I am defining a function for the derivative. Okay. Now let us implement our actual forward pass and backward pass. Now epochs I am taking is 1000. My learning rate is 0.1. Number of neurons in my input layer are 2. Number of neurons in my hidden layer are 3. And number of neurons in output layer is 1. Now this one is compression. This you can't change when you are implementing this XOR gate. But you can change the number of the neurons that you want for the hidden layers. Okay, this input 2 and output 1 will not be changed, but the number of neurons for hidden layer will be changed. Okay, now I need a weight which is connecting me input layer to hidden layer. So that I have initialized here with some random number. At the same time, I need a bias for that particular calculation. Okay. Now I need weight again to the connection which is containing my hidden layer to the output layer. Okay. So that is what the W out and I need the bias again for the same one. Okay. Now how many epochs are there? Those many times I will perform the forward pass and backward pass. Now how will be your forward pass? Your each input will be multiplied with the weight. Then you will add bias to it and then you will apply the activation function. Okay, now here I am taking the x as an input, but what is x containing? It is an array with these values. Okay, now once I have got the output, what I will do, this is the output available at the hidden layers. That is, as we have seen in the last example, that is at the nodes 4 and 5. Now I want the final output also. Again, that output will act as an input to me and that should be multiplied with the weight W out, add bias, apply activation function and we will get your final predicted output. Okay. The output that I have obtained with one forward pass. Now, what I want to, first I should find out the error. Error is found with a very simple formula that is the difference between the predicted output and the target output. That is the y minus output. Y is your target output and the output is containing the predicted output. Now, what I want the derivative of my output. Okay, so by applying the derivative sigmoid function, I will find out the derivative of that output. Now, this formula is giving me what? The error at the output layer. Now, this error at the output layer will act as an input to calculate the error at the hidden layer. So that is what we are doing. First, we should find out the transpose of the weights which are connecting the output layer to the hidden layers. Okay, because we are moving in the reverse direction. So the rows and columns should be reversed. Then apply derivative on the output which is available at my hidden layer. Then what I am doing, whatever is the error that is multiplied with this output. Okay, and again at this point I have obtained what is the error at the hidden layer. Okay, and this is the error at the output layer. So these two variables will be used to update my weights at the hidden layer as well as the output layer with multiplication of the learning rate. Can you see here that I am multiplying it with the learning? Okay. Now, when I am calculating the bias, simply I am multiplying with the learning rate. I don't use the output here. Okay. Now, with this one, I can output what is my input, what is my actual output, and what is my predicted output. Now, you can observe here. In your actual output, what you need, the first and last value should be near to 0, and the middle two values should be near to 1. But what you observe, all the values are near to 0.5. Means whatever parameters I'm using, that parameters are giving me lot of loss. Okay. Now I should find out the parameters which will take me close to the 0 and 1. Then for that purpose, I will change the number of epochs from 1000 to 5000. Only this is the one change I am doing here in this cell. The remaining all code is same. Okay. So here what you can observe, little bit improvement is there. Okay. Now 5000 I will make it as a 1000. Then what you observe here, this is what the output in which the first and the last value are close to 0, while the middle two values are close to 1. Now again, I will improve more epoch. Okay. Then I will see, is there any more improvement? Yes, there is more improvement. In the previous output, it was 0.92. Now it has been increased to 94. Now here in the next cell, I'm changing the number of the hidden lines to 6. Then what output you see here? The excellent output in which the first and last value is near to 0 and the middle two values are near to 1. Okay. Now here I am changing again the learning rate to 0.2. Okay. Then a very good change in the output you can observe. So like this, you should update your parameters and see what is the change in the output. Now this is the best output that I have obtained with the value of about 20,000, learning rate 0.2, number of hidden layer neurons as 10. Okay, this is the optimized output, the output which is giving me minimum loss. Now, during exam, what I am expecting from you is you should do such experiments, okay, and take your predicted output close to the actual output. But a very important thing here you should remember is all these formulas in which you are calculating the error and using that error how you are updating the weight. The forward pass is very easy. Nothing to remember about the forward pass because just the scalar product of bias is added to that scalar product and equation function is applied. Okay. But in the backward propagation, you should first calculate the error, apply derivative of your output, then multiply both, then you will get the error at the output layer. In the same way, you will get the error at the hidden layer. Then that error should be multiplied with the learning rate and the corresponding input to get the updation in your weight. And in the same way, while getting updation in the bias, multiply only with the learning rate and using these updated values, again our epochs will be continued. Okay, so this is all about your lab 3 in which I am achieving back propagation with the manual calculation which contains forward pass and backward pass. Thank you.